2.4 Physics, Horizontal Push from a Height. So let's start with those variables to consider. First, we have v naught x, which is the initial horizontal velocity, and then v naught y, which is the initial vertical velocity. It should be 0. Delta x is the distance the object travels, which is x minus x naught, and that is horizontally. Delta y is the height of the object that it falls from, or y minus y naught. T is the amount of time the object is in the air. It's the same for x and y. A is the acceleration, and ax is equal to 0 because we have constant speed. Ay is due to gravity, which is a negative 9.8 meters per second per second. Vx is the final horizontal velocity, and it will be equal to the v naught x. This is also because of constant velocity. Vy is the final vertical velocity. So the easiest thing to do is to make a table to separate horizontal and vertical, and then look at your 4 variables that you have from tube charts, right? Distance, velocity, time, and acceleration. So notice in this diagram, we have, get my handy dandy pointer, we have x naught and y naught. We have y is the height of the cliff, building, whatever, and x. We have v naught x and v naught y. We have vx and vy. We have tx and ty. And then we have ay, which is that negative 9.8. So, horizontal, remember, distance, x naught is 0. X is some value that you may or may not have to find. Time x, tx, v naught x, vx, and ax, which should be 0. Okay, so that's all horizontal, right? Vertical, if I can hit the right button, vertical is y naught and y, ty, v naught y and vy, and ay, which is that negative 9.8. Now there are some things that are just standard. Standard values is that time x is equal to time y. When you shoot an object horizontally, it still goes horizontal. It falls to the ground. It doesn't morph into two things. And v naught x is equal to vx for constant velocity. So let's look at an example. Nathan throws a rock horizontally from a cliff 112 meters up with a velocity of 24 meters per second. How far from the base of the cliff does it land? How long does it take to get there? And how fast is it going when it hits? Well, you have to realize that you need to separate your horizontal and your vertical. So we have x naught is 0, always, default. X, we don't know yet. That's in meters. V naught x is 24 meters per second. That means that Vx will be 24 meters per second. Velocity in the horizontal direction. Ax is 0 meters per second because we have constant speed. Tx will equal Ty, which we don't know yet. In the vertical direction, we have y naught being 0, y being 112 meters, v naught y being 0, and vy being some value we don't know. Ay is a negative 9.8, and ty is in seconds, which we still don't know. So here's how we have to go about solving it. Always find time first. In these problems, always find time first. Vertical, ty, is the square root of 2y divided by a, which should be 4.78 seconds. Horizontal, right? X is equal to x naught plus vt. There it is, happy day. Kinematic simple is back because we have constant speed in the horizontal direction. X will equal 24 times 4.78, and yes, it is a double rounding error, it's okay, is equal to 114.74 meters. Then we need to find the vertical velocity, right? Vy is equal to v naught y plus ayt, y, which really boils down to, since v naught y is 0, negative 9.8 times 4.78 is a negative 46.84 meters per second. You're going to have lots of problems to do in class. I will make separate helpful videos. Otherwise, thanks for watching.